Hey, welcome to The Explainer. Today we're going to talk about something that sounds kind of fancy, the highest common factor. But trust me, it's actually a super handy tool for solving puzzles you might run into, like, every day.
So, let's dive right in with a classic packing puzzle. You'll see what I mean.
Okay, picture this. You've got two different groups of things. How do you split them up into little bundles that are all exactly the same, without having anything left over at the end?
All right, let's get specific. Let's say you've got 12 blue pens and 18 red pens. Your mission is to make identical kits. Every single kit has to have the same number of blue pens and the same number of red pens. And, this is the important part, no leftovers. So, what's the biggest number of kits you can possibly make? Any guesses?
So how in the world do you figure that out? Well, it turns out there's a perfect math tool designed for exactly this kind of problem. It's like having a secret key.
And here it is, our secret weapon, the highest common factor, or HCF for short. You know, the name pretty much gives the game away. We're looking for the highest number that's a common factor for both our groups of pens. And a factor? That's just a number that divides another one perfectly with zero remainder, which is exactly what we need for our no leftovers rule.
And you know what's cool is that this is a universal idea. It's not just an English thing. Like in Hindi, it's called sarvadhik samanya gunankand, which translates to, you guessed it, highest common factor. It's the same exact logic, just in a different language.
Okay, so how do we actually find it? It's a super simple three-step recipe. Step 1, we list out all the factors for each number. Step 2, we see which factors pop up on both lists, the common ones. And finally, Step 3, we just pick the biggest number from that shared list. Easy, right? Let's get to it.
All right, here we go. Step 1, the great factor hunt. We've got our two numbers to work with, 12 and 18.
First up, let's break down the number 12. What numbers divide into it evenly? Well, we've got 1, 2, 3, 4, 6, and of course 12 itself.
Okay, now for our 18 red pens. The factors for 18 are 1, 2, 3, 6, 9, and 18. And boom, just like that, step 1 is in the bag. We've got our two lists of factors.
Now for step 2, finding the common ground. We're going to look at both of those lists and pull out the numbers that appear on both of them. This is the C in HCF, the common part.
So if we put them side by side, you can see the overlap right away. The numbers 1, 2, 3, and 6, they're on both lists. These are our common factors.
And that brings us to the final step, which is honestly the easiest part. We've got our list of common factors, 1, 2, 3, and 6. So, what's the H and HCF stand for again? Highest. So which one is it?
Yeah, looking at that little list, there's really only one answer, isn't there? It's 6. So the highest common factor of 12 and 18 is 6.
And there it is. That's the solution to our pen puzzle. We can make a total of 6 identical kits. And check this out. It works perfectly. You take the 12 blue pens, divide by 6, that's 2 blue pens per kit. Take the 18 red pens, divide by 6, that's 3 red pens per kit. See, every single kit is the same, and we have absolutely no leftovers. Pretty neat, huh?
So the main takeaway here, the HCF is your go-to tool whenever you need to split different things into the biggest possible number of identical groups. But that gets me thinking, what if we flip the problem? What if you wanted to find the smallest single box that could perfectly hold groups of 12 and groups of 18? Well, that's a whole other puzzle for another day. Thanks for joining me on The Explainer.